Alright, what's up guys? In this video we're going to pick up with some calculus here, and we're going to be talking about surface area. So we're asked to find the area of the surface generated when the given curve is revolved about the given axis. And so the given axis here is the x-axis, and we're given y is equal to 10 times the square root of x, and then we have our range for x here, which is going to be from 11 to 56. So pretty big numbers, maybe numbers that we're not used to the numbers being that big, but the process is still the same. So all we need here is the formula, and it's a relatively simple integral to compute. So we need the area of the surface, basically of revolution, because it's telling us to find the area when the curve is revolved about the given axis, in this case, which is the x-axis. Alright, so the formula for that is s is equal to the integral from a to b. And it's going to be 2 pi multiplied by f of x multiplied by the square root of 1 plus f prime of x squared and dx. So that's the formula. Okay, so as you can see here, we're given y is equal to 10 times the square root of x. Y is the same thing as f of x. So we'll just write it as f of x is equal to 10 times the square root of x. Okay. So the first thing we need to do is compute the derivative. So we need the derivative of f of x. Well, 10 is a constant that can be pulled out. We take the derivative of the square root of x. Remember, the derivative of square root of x is going to be 1 over 2 multiplied by the square root of x. So if we multiply that by 10, we would have 10 divided by 2 times the square root of x, which we know we can reduce down to 5 over the square root of x. So that's your first derivative of that function. Now we can go ahead and take care of this square root very quickly. So we'll have 1 plus, and we'll have 5 all over the square root of x. Don't forget that's being squared. So what that gives us is the square root of 1 plus. Now remember, we're squaring not only the 5 but also the square root of x. When we square the square root of x, we just get x. So this will be 1 plus 25 all over x. So add the square root of that, which we can effectively just write as the square root of 25 plus x all divided by x. Okay. All right. So we just need to compute the surface area now. So we'll have s is equal to the integral from 11 to 56, and it's going to be 2 pi multiplied by our f of x function, or our f of x, which was 10 times the square root of x, and then we'll multiply all of that by the square root of 25 plus x all divided by x, and we'll integrate all this stuff here with respect to x. Now this may look like a complicated integral, but it's not at all, because we know a couple things. The first thing that we know that 2 pi is a constant. 2 is a constant, but pi is also a constant. Pi is just a number. We also know that 10 is a constant as well, so we can bring that out as well. And so then we'll just have our integral from 11 to 56, and we'll have the square root of x multiplied by the square root of 25 plus x all divided by x integrated with respect to x. And if we simplify this even further, we'll end up with 2 pi times 10 times the integral from 11 to 56. And then this will essentially just become the square root of 25 plus x integrated with respect to x. So to integrate this is pretty straightforward. We can do a u substitution, picking u to be 25 plus x, and then that means that du would just be dx. Okay, and so essentially, let me get another sheet because we're going to run out of room. And so essentially what happens is, after we simplify the constants on the outside, we get 2 pi times 10, which is 20 pi. So this will be 20 pi. And we'll have our integral, and it'll be the antiderivative of the square root of u du. And we need to change the limits. So remember that u was 25 plus x. So to change the limits, all we got to do is substitute in. So that'll be 25 plus 11, which is 36. And then 25 plus 56. That's 81. And this is a fail-safe. I'm going to check. Make sure you're doing this. Yeah, 81. Just like to check to make sure. So now the new limits are going to be from 36 to 81. Relatively big numbers, but again, don't let that scare you. So now we just got 20 pi. The antiderivative of the square root of u, that's just 2 over 3, u raised to the 3 over 2. And then we evaluate that from 36 to 81. Okay. So when we stick in the 81 first, this would be 81 raised to the 3 over 2. So we'll put all that in our calculator. So we got 81 raised to the 3 over 2. So when we stick in, we'll get 81 raised to the 3 divided by 2. And it looks like we're going to get 729. So what we're going to have is 2/3 times 729. Oops, sorry. And that gives us 1458. So this would be 1458 all over 3. Let's see if that reduces. It does. It gives us 486. So that's what we get when we stick in the 81. We get 486. Now we'll plug in the 36 now. So this will be 36. Okay, so it got 36 all raised to the 3 over 2. And again, we'll put it in a calculator just to make sure our answers are correct, of course. So, and it looks like we get 216. So this will be 2 over 3 times 216. 2 times 216, I do know that one. That's 432. And we'll divide that by 3. And let's see if that reduces. I believe it does. 432 divided by... Yeah, it does. It reduces down to 144. So now what we have is 486 minus 144. So that's 486 minus 144, which gives us 342. But don't forget about the constant that was on the outside. So we got 20 pi multiplied by 342. So 20 times 342 is 6840. So multiply that by pi. So this will give us 6840 pi. And that is our surface area. So the final answer here, we compute the surface area here, is going to simply be 6840 pi. And, you know, I guess you could say units since we're We're trying to find the surface area. So that's your answer. All right. Not too bad, right? Hopefully. Pretty straightforward. All right. And that's going to be it. So let me know if you have any questions. I'll see y'all next time.